Hello, I'm Clément Gachot from EDF and the Research and Development Division of EDF. Just a quick introduction of EDF. We are French-based utility, but present in different countries in Europe and abroad. And our reason of being as a mission company is to build a net zero energy future with electricity, innovative solutions, and services to help save the planet and drive well-being and economic development. We have 90% carbon-free electricity thanks to nuclear, renewables such as wind turbine, PV, and hydroelectricity. I'm in a team dedicated to industry decarbonization, and I'm gonna speak about some technologies and also how to innovate on these kind of technologies. I will make a brief introduction about carbon emission reduction target for industry in EU and France, but also a quick introduction about heat in the French industry, and also we will speak about decarbonization technologies and innovations. So as everybody know here, I think we have the Fit for 55, which targeted to lower that 55% the global emission by 2030. And for France, for the industry sector, is reducing 35% by 2030. So it's really two quite important numbers, and 2030 is quite close. A quick disclaimer about what I'm going to speak, because I'm going to speak about electrifications of industry. Using electrification in order to decarbonize industry is the best leverage with available solutions. But in order to really decarbonize with electricity, electricity has to be decarbonized. Just a quick introduction of industrial consumption in France, but the ratio in the data that I'm going to present to you is quite the same in every industry in the world. So in France, the global consumption of industry is around 370 terawatt-hour. And the most important part of this consumption is thermal uses. And most of the thermal uses using fossil fuel for now. What we can see on this slide is on the 260 terawatt-hour consumed, we find 110 terawatt-hour of waste heat. So that represents 42% of the heat, which is wasted. This is quite important things for the next steps of the presentation. We see two main leverages to reduce, in order to significantly lower CO2 emission: recovery and substitution. I'm gonna begin with the technology that combine both. With heat pumps, it's just a quick disclaimer again. These numbers are calculated with French emission factors, so with French electricity and gas emission factors, and with a COP of 4. So with heat pumps, you can reduce up to 75% of energy. You can reduce up to 93% of emission, and you are recovering heat. I don't know if it's necessary to explain how heat pumps work, since there has been a lot of presentation and nice presentation from the colleagues here, so I'm going to continue. In the industry, there is technology already available up to 120 degrees, and for a few megawatts producing mainly hot water. There is demonstrator level technology for more than 120 degrees up to 150 degrees producing water or steam, and lower TRL for up to 200 degrees. On the 260 terawatt-hour of heat that we were speaking about just before, we think that the French market could represent 31 terawatt-hour for heat pumps. that could represent recovering 20% of the waste heat that we have already. So, and mainly in three industrial sector, 65% representing in three industrial sectors, paper, chemicals, and food industry. This is, yes, quite French-based, but in order to understand which could be a good target, but I think we are a bit late now. In the last net zero emission report from the IEA for net zero 2050, that stated that for light industries, we need more than 500 megawatt per month during the next 30 years. I think the report was done in 2021, and I think we are quite late. Yeah, this is the statement, and that shows that electrification could be a major role in order to reach the net zero by 2050. This presentation is coming from Swiss researcher named Cordina Pagos with the data from the Annex 58 of the IEA. This show you how solutions are available around the world. You can see that with heat pump and mechanical vapor recompression, you can go higher up to 280 degrees. And you can go with power from hundreds of kilowatt up to a bit less of 100 megawatts. I'm going to speak about another technology that I introduced just before, which is mechanical vapor recompression. This is only a compressor for vapor, so you can recover the waste vapor that you have in your process in order to higher the pressure with the compressor and put again in your process or in another process. You can put this technology in distillation, crystallization, evaporation, but also drying, which are most known processes in the industry, with energy efficiency ratio really high, between 3 to 10. I'm speaking about COP, not energy efficiency ratio here. Also, when the two previous technologies are not available, you can decarbonize with electric boilers, which is has an energy efficiency ratio upper than gas boilers. So it could be interesting also for energy efficiency, CO2 reduction, and lower the OPEX on maintenance. The market in France for this technology is estimated for more than 60 terawatt hour. But now most of this market is led by biomass boilers, but maybe in the next future it could be limited, and sometimes on industrial sites it's not quite evident to find the ground space available. Also, in order to decarbonize the industry, it's important to decarbonize the process. Here you can see some kind of electric furnaces. There is quite efficient solutions with electrical furnaces, and more sectors are interested in these technologies, and we are estimating this market in France for more than 80 terawatt hour. On kind of some sectors, there is R&D needed in order to develop the right technologies for the right product. Yeah, this is a statement. We need to accelerate. This is for a research done for heat pumps. The survey showed that amongst 27 experts on heat pumps and heat recovery, we can see a lot of indicators, but I'm gonna just do a quick focus on three, which is high OPEX, which is the main barrier for industrial heat pumps. High OPEX, expectation of short payback periods by industry, high CapEx, and fuel price too low. So in order to tackle this barrier, it's important to maintain the CapEx subsidies on existing already in EU with the Horizon Europe or Innovation Fund and so on, which is quite good. And in France, the France 2030 program, which is helpful. But it's also important to think about OPEX subsidies that could help high temperature and very high temperature heat pumps with lower COP, because the COP is defined by the difference of between the output temperature and the input temperature. So when you have process with high temperature needed and you have low temperature wasted, you can't do without that. You can reduce the temperature, but sometimes the COP is lower than the spread between gas and electricity. So sometimes OPEX would be needed. For now, there is not real program in order to subsidize this OPEX. Also, for the countries that have energy efficiency certificates, it needs to be fully available for this technology, which is not already the case. On this main barrier, I would like also to insist in maybe the most important point in order to go fast, is one not the least, but not the least. We need more workforce in these industries. When I say in these industries, I am speaking about the industries that produce the technologies that I was speaking about. In order to install the technology, operate the technologies, we see already the limit of the workforce available. So, speaking about a bit of innovation. In EDF, we have worked on 3 main projects in the last years in order to answer to the market with the very high temperature heat pumps. We have 3 projects. The first one was led with GCI, and in order to produce 130 up to 40 degrees, actually, with natural fluid, with water, in order to answer to main industry for food and chemistry. And we hope to spread these technologies in the next years. The other one was in EU-funded projects in the Horizon Europe, which is named Bamboo. And the main objective of this project with our 2 main partners in this work task, which is AIT and ArcelorMittal, was to develop and test in labs and on the test facilities of ArcelorMittal and EDF, the 5-bar steam heat pumps. The last one, which is one I'm gonna do a quick focus, is the development of transcritical heat pumps, which permit to get some high COP in order to produce heat up to 150 degrees, mainly for dryers. And we have done a project on the paper industry that I will present. So the Transpac project. The Transpac project is an ADEME-funded project with the partners on the slide, which is VEPA for the customers, so the paper industry, EDF, a subsidiary of EDF named Dalkia, which is operating district heatings and working in the decarbonization of building and industry, and also a university named ARMI. The goal of this project was to build the first industrial demonstration of a transcritical HFO heat pump at full scale, 600 kilowatts, on a dryer. The industrial site was the VEPA Greenfield site in the east of France. The technical target was to preheat the inlet hot air from 97 to 138 degrees with a COP around 4, using mist at 80 degrees as a waste heat source. The quite important point here is the transcritical permit us to have a COP doubled compared to a subcritical heat pumps. The duration of the project is 5 years. The commissioning of the demo was this spring in 2023, and the demo is running, and the COP target is reached in July 2023. So just on the right of the slide, you can see the integration of the heat pump in the dryer. So as I said, we are recovering the mist. at the output of the dryer, and we are using the heat from this mist in order to hot the air that we put inside the hood of the system. Here I just put all the things I've said in a perspective of innovation cycle. So for this project, for the transcritical heat pump project, this is coming from an idea in 2010 from Jean-Louis Perreux and Bourrique. And after it led to a thesis done between 2012 and 2015. After we have patented these technologies, just in the thesis, we have done the 30 kilowatt lab demo, okay? So after we patented these technologies and after we launched, thanks to the ADEM, a subsidized project in order to demonstrate the full capacity of the technology. During this project, we've done a lot of things, consolidate the design, de-risking the industrial design, doing the conception, the integration on site, and the running for the demonstration. Now we are able to decarbonize dryers with these kind of technologies, and that show the time that it takes in order to have efficient solutions. So the important thing is when we decided in 2010 to develop these technologies, and now we are in 2023, it takes 13 years. So if I have something important to say, if there is new regulations that can change the way that the technology could be developed, it's important to give to not impeach the efficient solutions to appear on the market and to reduce I would like to finish on, in order to give a signal also, we have some laboratories available to test heat pumps, industrial heat pumps. So I'm saying that for industrial customers who are interested in heat pump solutions, we can help to de-risk technologies and assist manufacturers in their developments of new high temperature heat pumps and facilitate the integration of heat pump in the technology mix and new architecture. I would like, we are here to speak about energy efficiency. I think one of the things that could be changed in the next future is not avoid to speak about energy efficiency ratio, but maybe speak about energy efficiency ratio that takes care of the waste heat that you can recover. Because just to give an example, when you have a dryer, you can do it with hot air, but you can also do it with superheated water, superheated steam, sorry. It is two technology really different. And with these two technology difference, you can lower by 30 to 40% the efficiency between hot air to superheated steam, which is more efficient. But it's not, and the efficiency you can reach with the superheated steam dryers is quite close to the minimum energy that you need to dry your product. But if you add the recovery effect of MVR or a heat pump, you can lower to a third of the minimal energy needed to dry the product. So energy efficiency is when you are only focused in the existing solution, but if you are thinking about the best process as an energy efficiency and the best solution as an energy efficiency and recovering heat, it could give the best solution for your industry. And that's the conclusion of my speech. Thank you very much.